Hi, welcome to Unit 5, Day 7. This is Part 2b, Example 1. So in this first example, they're asking us to write the balanced equation for the combustion of C3H8. First thing I need to do is write the unbalanced equation by knowing what my reactants or products are. And remember, for a combustion reaction, your reactants will always include O2, and your products will always be H2O and CO2. So what I'm going to do is I'm going to write the C3H8, because that's my reactant as well, and then O2 as my reactant. Finally, I'll have CO2 and H2O as my reactants. Okay, so the next thing I want to do is, when you're balancing equations, we're changing the coefficients in front of the molecules so that we have the same number of atoms on both sides. So I'm going to go ahead and figure out what those coefficients are. But to do that, I need to sort of keep a tally of how many atoms I have on each side currently. So for carbon, on the reactant side, we have 3 carbons. Hydrogens, we have 8. Notice I'm just using the subscripts there. For oxygens, we have 2. On the product side, we currently have 1 carbon, and we have 2 hydrogens. And then for the oxygen, because it's in 2 separate molecules, we have to add those together. So we have 2 from the CO2 and 1 from the water, so we have a total of 3. Okay, so now that we've done that, remember our strategy that we learned in the previous video is to balance the oxygens last. So we're going to balance the oxygens last. So let's go ahead and focus on the carbons and the hydrogens. So starting with carbon. I have 3 carbons on this side and I have 1 on that side. So I need to get 3 carbons on the product side. And in order to do that, I need to change the coefficient in front of the molecule with carbon in it, and that would be CO2. And the coefficient I'm going to write here is a 3. And the reason why I'm going to write a 3 here is because if I have 3 carbon dioxide or CO2 molecules, then I'm going to have 3 carbon atoms on that side, because each CO2 molecule has a single carbon atom. So the other key thing to remember is, once you change the coefficient of a molecule of a compound, then the other element in the compound, you also have to change the number in terms of your tally. So originally I had 3 oxygens, but now I have to recount that. Because right now I have 3 times 2, so 6 from the CO2, and I still have the 1 from water. So right now I have 7 oxygens. I'm not going to do too much with that right now, but I just need to keep track of it, because remember, we balanced the oxygen last. All right, so now let's go ahead and try and balance our hydrogens. I have 8 on this side, and I have 2 on that side. So I need to change the coefficient, the number in front of H2O, to get them to be the same. So to figure out what that number is going to be, I'm going to ask myself, I notice I already have 2 hydrogen atoms in the water molecule. Well, 2 times what will give me 8, because I'm trying to get them to be 8 on both sides. And that number would be 4. So if I change the coefficient here to a 4, that changes the number of hydrogens. 4 times 2 will be 8 on this side. And once again, I can't forget, since this is a compound, it has more than one type of atom, I also have to change the number of oxygens, because I've modified that. So I have 6 from CO2 plus now the 4 from water, giving me 10. All right, so far my carbons and my hydrogens are looking good. They're balanced on both sides, same number on both sides. So the last thing I need to do is balance that oxygen. So right now on the product side, I have 10, and I only have 2 on the reactant side. So I got to ask myself, well, the only molecule that has oxygen in it on the reactant side is O2, so that makes it easy for me since that's an element. What number can I multiply the O2 with in order to get 10 oxygen atoms on that side? And that number, of course, would be 5. Because 5 times 2 will give me 10. So now I have 10 on this side. And now I have a perfectly balanced equation. All right, that's it for example 1. We're going to do example 2 next.